Welcome. This is part 4 in a 6-part series reviewing your, what I'm calling the outline packet for your midterm exam. We're on to bones here. And osteoblasts and osteoclasts are reviewed on the previous review. Again, the blasts are the builders. They put calcium into the bone, and the clasts are the breakers. They take the calcium out. They're implicated in osteoporosis as your clasts are being overactive. The next bullet here at number 11 is long bone structure. Recall the major components of a long bone. You should have an idea about the glove that's covering the bone, that connective tissue protective glove, which is periosteum. Again, peri means around, osteum refers to bone. Recall that on the tip of the bone is a cartilage pad, which is referred to as articular cartilage. And recall cartilage's role as a agent to reduce friction. The major ends of the bone, the epiphysis, of which there are two, and the diaphysis, for which I am pointing to the wrong location. The shaft or the diaphysis. In between the epiphysis and the diaphysis, you have the growth plate or epiphyseal line. This, as this grows, the diaphysis pushes away from the epiphysis, which lengthens your long bone. As you continue to age and you get towards that 17, 18 mark, this starts to ossify and close over, which indicates that you're done growing there. Quick note, which I think was also mentioned as far as the microscopic anatomy of bone. Recall that around the central canal there are these tiny satellite halls called lacuna, and in those lacuna are where the osteocytes sit and live. Moving on to fractures. Fractures, you should be able to answer. I believe you'll be given an X-ray, and you need to answer the standard 3 questions when examining classifying a fracture. You do not have to memorize epiphyseal, spiral, or any of those. But given a, let's see, again, we'll test out our drawing skills here. Given a fracture, here's the bone, and let's see if we can. Given a bone and a fracture, you should be able to answer whether a fracture is simple or compound. Incomplete or complete, and displaced versus non-displaced. So in the example I have here, simple compound, think more than one. So in a compound fracture, the bone and the skin is broken. So in this example, you would say this is a compound fracture. Again, sometimes this is difficult to tell from an X-ray, but often you can see the faint outline of the muscle and the border of the flesh, if you will, around. So again, in a drastic fracture, sometimes you can see that skin has been broken. If it looks intact, the border of the flesh is intact, you would call it a simple fracture. This is an incomplete fracture. Again, is the bone broken in two, or is it dangling, if you will, like in my picture here? Displaced versus non-displaced. Again, continue along the axis of the bone on one of the ends. If the other end of the broken bone divests away from that line, then it's a displaced fracture. So this would be a displaced fracture. Skeleton is next. you should know the difference between the bones or the components of the axial versus your appendicular skeleton. Here's my Herman interpretation. Not bad. Not bad. Okay, so your axial skeleton, again, if you were to draw a line down the axis of the body, stop before you get to the pelvis. This is your axial skeleton. Includes the skull, the sternum or breastbone, the ribs, and the vertebra. The appendicular skeleton, think appendages, so these are the arms, the legs, and what we call their girdles. So this includes your femur, your tibia, your fibula, again, all the bones in the foot. Also includes your pelvis. At the pectoral girdle, this includes your scapula, your clavicle, and then all the associated bones of the arm and the hand, humerus, radius, ulna, etc. There is, the next point here. I can't go through all this right now. I would highly recommend, there are YouTube videos posted under, I believe, Chapter 6, me sitting in my office with bones in my hand going through right versus left. You will be given a picture of a bone and asked if it's a right or a left, and you should be able to make that determination. Again, I think that's one question. Difference between male and female. Again, the most important bone you want to look at is the pelvis. Recall that in a male, in a male, well, let's throw in the female here too. So this is male and female. I don't want to spend too much time printing up this. I don't think it's fixable. Nonetheless, in a male on the left here, you want to look at the, in essence, the male's pelvis is tall and more heart-shaped. Probably, again, the most important thing you're going to examine on a diagram is the pubic arch or pubic angle. In the male, this should be less than 90 degrees. It should be somewhat acute. In the female's pelvis is more broad and round, and her pubic arch should be about 90 degrees. It should be it should get about a right angle out of it. On your sheet, you also have joints as the next component. I will be going over that, I believe, on the next review.